In this particular example, we've been asked to evaluate the integral of e to the x times cosine x dx. We're going to use integration by parts here. Now, some of you may want to use tabular integration here, but you would find that it results in a small problem, and you can experiment with that after you've looked at this particular example, and you may see why that problem arises. Well, going back to my integration by parts, I'm going to let u equal e to the x. So the differential du is going to be equal to e to the x dx. I'm going to set dv equal to the cosine of x dx, so therefore v is going to equal the sine of x. I then state my formula for integration by parts. So I can now say that the integral of e to the x cosine x dx is going to be equal to e to the x, and that's our value of u, times sine of x, that's our value of v, subtract the integral of sine of x, that is our v, times e to the x dx, that is our du. In the next line, all I've done is rearranged that integral slightly, and what you'll notice is that we have to use integration by parts again. So now I'm going to evaluate that integral, the integral of e to the x sine x dx. Again, I'm using integration by parts. I'm letting u equal e to the x. Its differential du is going to be equal to e to the x dx. I'm going to set dv equal to sine of x dx. So v is going to equal negative cosine of x. State my formula again for integration by parts. And now I use that so I can state that the integral of e to the x sine x dx is equal to e to the x, that's our value of u, times negative cosine of x, that's our v, subtract the integral of negative cosine x, that's our v, times e to the x dx, the e to the x dx being our du. When I simplify that expression again, I get negative e to the x cosine x plus the integral of e to the x cosine x dx. Then you have to ask yourself, we're doing integration by parts again? Maybe there's something we're missing here. Well, let's go back and put all these pieces of information together before we start trying to do integration by parts again. So, what we had found on the first screen was that the integral of e to the x cosine of x dx was equal to e to the x sine x minus the integral of e to the x sine x dx. Well, we evaluated that integral and we got what we have now in these brackets. So I've got that it's equal to e to the x sine x subtract, and then in brackets, negative e to the x cosine x plus the integral of e to the x cosine x dx. Next step, all I've done is drop the brackets and change my signs. So I now have e to the x sine x plus e to the x cosine x, subtract the integral of e to the x cosine x dx. Remember, we were stalled at that point and asked ourselves, should we do integration by parts again? Well, let's take a look at our original question. It was the integral of e to the x cosine x dx. Hey, look, our last integral is the integral of e to the x cosine x dx. It occurs on both sides of the equation. Why don't I add that integral to both sides of the equation so that I end up with 2 times the integral of e to the x times cosine x dx, and that would now be equal to e to the x sine x plus e to the x cosine x. And then it's merely a matter of dividing both sides of the equation by 2. So now I have the integral of e to the x cosine x dx is equal to 1/2 e to the x sine x plus 1/2 e to the x cosine x. Common factor out a 1/2 e to the x, and you're left with in the brackets a sine x plus cosine x, and then we tack on plus c, where c is an element of real numbers.